Okay guys, we've got you back here on this foot peg mount project for my flat track racing motorcycle. Okay, and on the last video you guys saw me program the left foot peg mount. In this video we're going to be working on the right foot peg mount. So, one of the first things that we're going to have to do here is make our setup. And we might end up splitting this video into a couple parts because this is a little bit longer part to program. So what I'm doing is I'm going to select my X and Y axis, and if I select that edge right there as my axis, right, as my X axis, you can see that it orients the material in such a way that it actually optimizes our use of material. So if I had it this other way, we would be machining away all this waste material. But if I select this edge, it orients the stock material in a much smaller space. We're going to go ahead and flip our x-axis and select model box point, and we'll pick up that corner over there. And remember, what I've said is that we try to program off of the model, not off of our stock material. If we program off of the model, this model's never going to change. It's defined dimensions. It's never going to change. The stock material, maybe I cut it too short or too long, or from the manufacturer it's too wide, right? It can change a little bit. This model won't change. So we really theoretically can't go wrong. We're going to go over here and click Add Stock to All Sides. We've got to do a little bit of math here to make sure these numbers end up nice and even. We want the depth to be exactly 2 inches. And the math says that we should have 0.04169 inches as our offset. Probably at the machine we'll be happy with 0.0417. We can measure down that far. We'll probably be happy with that at the machine. But for now, let's get that to be exactly 2. Our height, we want to end up with exactly 1 inch. So we're actually going to add 20 thousandths to Z plus, and then we're going to take 1 inch and subtract 697 thousandths from it, and that leaves us with 303 thousandths. Okay, so we've got by 1. And let's get this to, I don't know, we'll just add 50 thousandths to either side, and we'll be happy with it. Okay, so we've got our stock set up here. So the first thing we're going to do is we're going to create a facing operation. With a 3-inch face mill, 4,000 RPMs at 20 inches per minute. Model top on all of our heights. We want this to extend 1.5 inches past the end of the material. And we're going to turn off our lead-ins and lead-outs. Okay, there's our facing operation. Now we're going to end up getting this thing roughed out to shape. So we'll do 2D adaptive clearing. We are going to select a 1/2 inch flat end mill. We'll see if we can get everything cleaned up here. Okay, so that allowed me to click this outside contour as our geometry. Had to fiddle with it a little bit to get it to go. Model top on everything except we're going to go to model bottom for our bottom height. We're going to leave 5 thousandths of material in stock radially, so on the edges. We're going to drop our optimal load down to 0.1. And everything else should be good. Let's see what this looks like. So the one thing we do want to select, we'll probably do multiple depths. That looks pretty good. Looks like it's going to get to all of our contours here. So we'll then clean up. Afterwards, we're going to clean up the contour. See if we can get it to let us, there we go. With the same 1/2 inch end mill running at 20 inches per minute. Model top for all of our heights. Again, bottom height is going to be model bottom. We're going to select wear on our compensation. That's going to allow us to dial in these dimensions at the machine. So we can create a wear offset in the control and sneak up on our final dimensions here. Everything else looks good. And we've got a contour. So let's take a look at our simulation and see where we're at. So here's our facing operation. And we're going to rough out the contour of this part. Okay, that looks pretty good so far. I think what we'll add next is the chamfer around this top outside, and then we'll go to our holes. So I'm going to go 2D chamfer. I'm going to select this top contour. We want to have a 3/8 chamfer mill. 4,000 RPMs, 20 inches a minute. We're going to reduce our lead in and lead out feed rates. Model top for all of our heights. We're going to go with a 50 thousandths, or we're going to go with 0 on our chamfer width. And our chamfer tip offset, we're going to go with 50 thousandths. Wear offset. And let's take a look and see what that looks like. Perfect. We'll go ahead and spot drill all of our holes. And if you take a look, you can see the tip of the chamfer mill with these settings is going to drop down into the hole and spot drill that hole for us. Our cycle is just going to be a drilling rapid out.